Okay, welcome to activity 123, the Apple Avalanche. We're going to be doing a lot of different things in this activity today. So, we've looked at Turtle, we've looked at using Turtle Python, we've looked at what it can actually do, but we haven't really added much user interaction yet. The last game that we created, we were able to click on the screen and actually make objects appear and disappear, which that was where our timer came in and where our scorekeeper and our leaderboard came in. But now we want to start using other things such as the keyboard. So that's what we're going to be using in this activity. So goals for today, we're going to create a game that the user control from behavior with the keyboard. We're going to manipulate some lists, and we're just going to use best practice when commenting out our code like we have been. Typically, this is a pair programming activity with us being distant learning. We're going to do this individually. I do have this walkthrough that will allow you to overview it as you go through, but it's kind of hard to do that pair programming since we are all at home online. So let's take a look. So the Apple Avalanche. The first thing we're going to do here is we actually have to go into this hamburger menu here because we have to download this code. So we're going to hit download and it's going to give us a zip folder. The reason we have to download this is because there's actually a lot of files we have to access. We have an apple, a background, and a pair that go along with the main.py file. So these are all going to be included within our program. Once you download that, you can just open it up. You might have to unzip it if you're running a Windows. Mine automatically unzips when I click on it, and it will expose these files here. So what I'm going to do, I'm just going to pull this off to the side because I'm going to use these in a little bit. But we are going to do this in Replit. So if you want to go to your Replit page, you can create a new REPL. And we are going to use Pygame for this. And this is going to allow us to bring in those additional files. If we used Turtle, Python Turtle, or TurtlePy, it actually doesn't let us import additional files. So we're going to have to use Pygame for this. And I'm just going to name it Activity 123. Okay, so we have this here once it loads. So now we want to bring in these files. It's easy enough just to select them all and drag them into the files pane. If you want to upload them the standard way by using the three dots here to upload, that is fine. However, you can get them in this panel. You are going to get a overwrite message that says main.py, it already exists, it's going to overwrite it. Yes, you want to do that. Reason being, it's going to bring in our source code. If we don't overwrite it, it's just going to be this empty file. Okay, so now we see all of our documents. We just have image files and then we have our main. So let's see what this does. Okay, so this is going to just load an apple on the screen. That's all we got so far. Because we're importing Turtle, like we always do. We are defining a variable apple image, and that variable has just got the value of the image file, which is perfectly fine. Technically, we don't even need to define this image if we don't want to. If we wanted to add the shape, we could just put the GIF file here, we could put it down here, and it would pull it respectively from the files menu that we have. But I think defining it as a variable will make it so we can change this if we want to later. We're opening up that turtle screen. We're setting a base width and height. We don't technically need to. I'm just going to leave this as the standard. We're adding the shape, so we're pulling that image, but we're making it aware that we're pulling the image. So without this line of code, we actually wouldn't be able to see that apple on the screen. What this is doing, it's saying, okay, you have the turtle image that you're using, the standard turtle. This replaces it with the variable that you're assigning. So this will replace it with that apple file. So saying we have apple turtle, and then we're defining our functions. So all we have right now is we're drawing an apple on the screen, and then this WN update is allowing the screen to actually update. I believe if we comment this out, it should still update the apple because we're stopping and running it again. yeah, it had no issue with it. Standard practice, you do want to do this WN update because it'll make sure that the program actually updates when you go to run it. If you don't do that, if you're defining other functions, it may not run properly. Uh-oh. Of course, now it's not going to run, right? Run. Let's try reloading this. There we go. Okay. So just have that in there. It just allows it so it updates whatever functions you're running. We're calling the function to actually draw the apple. And then we have our main loop. Okay, so let's take a look at the next piece here. So we define those. That's our main source code that we're running. Perfect. This shows you the extraction if you need to extract them a different way. If you want to do the open with, I know you all have done this, so follow it if you need to. If you don't, it's there. Run the main py. We don't have to rename it because we know that Replit doesn't like us renaming this file. They want that main.py, so we can leave that alone. Okay, observe the source code. It defines a function drawApple that takes activeApple as a parameter. What kind of object is the activeApple? Okay, so if we look at here, drawing the activeApple, what that is, it's actually the turtle. So that's replacing our turtle object. So the apple is replacing the turtle at the beginning of the program, so that way we can actually see that apple on the screen. So we want to modify your code so it uses the pear image as shown below instead of the apple. Okay, so let's see. So we have the pear image here. So this is actually easy enough in the sense of all we have to do is replace this with pear, and it should replace that image for us. Perfect. If we look at our code, because it's named apple image pear, this isn't the best way to do it. We should actually go through and replace all these apples with pear. But for the sense of just seeing if it worked, I'm just going to replace just the image name because I think it's only going to have us do that once. Okay, for the typing game, you'll need a static tree image in the background. So something we just have available so the apples can fall from it. So we're going to create a scene with a tree with an apple on it. So we can add the following line of code. Best part about this is it already puts it so we can just copy and paste this right in. So I'm going to add this right under my loading turtle screen so it brings that background image in as well. Perfect. And I'll actually change this back to apple because we're going to have the apples fall. Okay, so we have our apple and we have our static backgrounds there. So modify your code by defining and calling a function that causes the apple to fall or move to the ground. The following functions may be helpful in terms of finding out where to start and determine its position. Okay, so essentially we want to make our apple fall to the ground. Need help? Let's see what they give us. You'll recall from lesson 1 you can use the following turtle methods to move your turtle. Forward, right, left, go to, set X, set Y. Be sure to consider how your code might need to change if you were to add multiple apples, all of which could start at different XY coordinates. All right, so let's look at what we actually have here. Okay, so if we look at our actual screen here, I just want to take a look at what's going on with our axis. So first off, we know that this apple is sitting on a base axis. We have one, oh, that's straight, one here and one here. And let's see, let me add in, we know that it always starts at what, 0, 0. So with that, where do we have at the bottom? Typically, I think this is a negative 180. Up at the top here, we have about 180. Could be plus or minus. It might be 200 depending on your screen. And then same with the sides. We have 180 over here. And we have negative 180 on this side. Okay, so this is our base coordinates for where things actually fall on the screen to begin with. So according to our directions here, we want to make, oh, let me shut this annotate off. We want to make our apple fall to the ground. So in looking at that, we want it to fall on the y coordinate, not the x. So let's see, if this is 180, let's say this is about like 150. So if we wanted to get it to fall to the ground here, we're going to have to create a new function. And for that function, we can actually, let's see, we can do, let's just call it define, and we'll do drop apple, just for a standard name. And we actually don't need to even put any parameters in there. So we can just leave that empty. And with those parameters empty, there's actually a couple different ways we can do this. Typically, like we saw in the directions here, they actually give you things you can use, forward, right, left, go to. For coordinates, if we know about what the coordinates are, we're going to use this go to command. So in this, we can actually just define, let's see, apple, go to, and we can have it go right to the coordinates where we want it to fall. And we were saying that's about 150. We could do 140. We're not changing the x, we're only changing the y. So we can do 0 and then negative 140 for that. Once we have our function defined, we can then call the function. So we have drawing the apple, and we also want to drop the apple. Now if we run that, let's see what happens. Let me get rid of this annotation here. There we go. Okay, so it drew the apple and then it dropped the apple. Currently, when it does drop the apple, it is going to draw this line here. And I think it actually makes note of that in here. Okay, so because the apple is a turtle, by default it draws a line, yep, whenever it moves. If not already, modify the code so the apple does not draw the line. So in getting rid of that line, we've actually done this before. If you don't want it to draw the path or you don't want it to draw that line, we can actually add a line of code here and we can put it right in defining that drop apple, where we can do apple pen up. And what actually works for this, if you want to try it, you can just do PU and that'll actually call it as well. So let's see if that... Perfect. So now we get rid of that line right there. So the other thing we actually want to look at here is in one of these steps, okay, be sure to consider how your code might need to change if you were to add multiple apples. Okay, so that changes a little bit of what we got going on. Up here, it actually defines some things that we can use for functions and how to call them. So currently, we have 0, 140, which will drop our apple. But that's if our apple is starting at coordinate 0, 0. What if our apple's starting over here? Now this 0, 140 isn't going to work. But what we can actually do is we can get the current x coordinate. We can even just copy this. And what this will do if we replace it with the 0 is it will take wherever that current x coordinate is and define it where the turtle is currently located. So that way we don't have to, actually that's going to be apple, sorry. That way we don't have to try to guess. We can just, if it's a first apple, wherever it is, it's going to take that initial coordinate and it's going to drop it at the 140 because that's essentially where the ground is. And I might actually change this to make it drop a little further. So let's see. Okay, perfect. So now it's right on the ground. So it'll still take that coordinate of wherever the apple starts on the x, and it will just drop it down to the destination of wherever we want it on the y. Okay, perfect. So we have that working, but using this go-to, there's actually other options. So we saw the set x and the set y. We can actually use that as well. So instead of using this go-to option, we could actually do apple set y, and this will just set it to that 160 that we're looking at. And if we comment this out, it's actually going to do the same thing that we just did because it's going to look at that, setting the y coordinate of the apple to 160. And I'll actually change this so you can see that it's running correctly. I know Replit is iffy sometimes. It's actually very slow today. But see how it changed that. So it still is running. It's still setting that Y coordinate. It's actually just getting rid of this go-to so we can kind of clean up our code a little bit here. So either of these that you have will work. There's not just one way to do it. I'm going to leave it as this one here. I'm actually going to get rid of this line because this is the simpler way to do it. But like I said, if you have it the other way, that's fine. It might just need to be adjusted as you go through the program. We are going to be adding different steps to this. We're only on step 7 here. So we might need to adjust it later on. So I'm just going to keep this apple set y negative 160. Okay, so let's take a look at the next piece here. So we have that working perfect. Got all this. Apple draw, yep, we got rid of the line. So key presses. So now we're actually going to get it. So for your typing game to work, apples will fall from the tree whenever the user types the letter that's displayed. To do this, the program needs to detect the keys that the user presses. Being able to detect the keys a user presses is vital to providing additional interactivity between the user and a program. Let's explore how this works and add the functionality to the typing game. So the program in the code editor below draws the letter A when you press the A key. All right, let's see how this works. So if I press A, there we go. It's a little slow. Let me try it again. Okay, so you don't even need to click on the screen. You can just press A for that to actually work. Okay, so let's see how this works. So importing turtle, we're doing the same stuff we always do. It's defining the turtle as drawer. We're setting that up here. We got a function, draw. It's going to draw a blue A, sets up the font, all that stuff. And then we're actually calling this on key press draw A and then A here. So it's going to, when the key A is pressed, it's going to look for this. Technically, I guess if we change this to B, it would still draw A. Let's try it. So if I press B, yep, it still draws A. So that's just looking for what you're typing. And when it's looking for it, it's actually doing this WN listen here. So that's listening, or I should say looking, to see what you're actually typing on your keyboard. What's also neat about this is in changing this, I can actually use the word space, and that's going to use the space bar. So if I run this again, because it's listening for whatever I type, but it doesn't know, you're not going to type the word space, but if I hit the space bar, it's going to still display that A key. And with these parameters, I can change these to whatever I want. Let's see. To purple, I can change the font size, whatever you want to do here, really. Okay, so let's take a look at what it wants us to do now. Okay, so here, additional information that defines the on key press. This is in your list of defined Python commands that I gave you guys, so that will be in there. So modify your program to make the apple drop when the user presses the A key. Okay, so let's see. The main pieces here are this listen and this WN on key press, so I'm actually just going to copy those. And going back into my program, okay, let's see what we have here. Under my drop apple, I can paste those in. And we don't have a draw A, but we have a drop apple when the A key is pressed. And it can listen for that. So let's see what that does. Oh, we gotta get rid of this because it's just gonna drop it otherwise. Okay, so it starts there, and now it should listen. You can't see my keyboard, but if I press A, it'll drop it. Okay, I have to click into here in order to do it. So let me do that one more time. If I run this, I click into the actual Python graphics and hit A, it will drop it down to the point that I'm looking for. Perfect. Okay, So that worked. Perfect. Let's see what we get going on next here. Okay, modify the program. We did that. Choose one of the following. Add a function that will draw a white letter A over the middle of your apple before it drops to indicate the user what key they're supposed to type. So this sounds like a elementary game where it would be like, oh, the letter that pops up, you type it, and the apple drops. And then easier, we're not gonna do easier. We'll do the harder one because I don't think this is that much harder. Let's see. Once you've gotten the letter to draw, you may notice it doesn't draw right in the middle of the apple. Okay, let's draw it first. So, in looking at this, you may want to reference code above to see how the right function works. Okay, so we want to use the right function, which we actually have here and we've used in previous exercises. So I'm going to copy this. And actually, I'm going to copy this whole thing here. The draw A, because we're going to be using that right function. And I'm going to go back to my program here. So we have the drawing the active apple and we have drawing the shape. I'm actually going to paste that code in here. We don't need all of it. We're not defining another function. We're just adding to the function we already have. So we have the apple, but now we want to add the white letter over it. So we have the apple image. We're not going to do the drawer. We're going to do our active apple. Active apple. And we do want to do the color, which it asks us to do white. And then we're also, let me copy this. We're going to do the active apple right. Write an A, font, we can keep the font the same. I'm going to make it a little bit smaller. I'm going to do like 60. And then let's see what we get. Let me stop this. Oh, what just happened? Okay, there we go. Okay, so we get the A. I click here, hit A, it'll drop it. Perfect. I'm going to make this a little smaller. I don't like how big that is. I'm going to do 40. We can keep it bold, that's fine. Okay, perfect. So we have it there, but as you can tell, it's not in the middle of the A, and that's actually what it's telling us here. So it's saying like, okay, you use the right function, but here we go. You use the right function, but now we actually need to position it. So if you've set the size of the letter font to 55, you can use 18 as the X offset and 40 as the Y offset, but don't forget to modify that by the X and Y coordinates. Oof. Okay, math. So now we actually need to position that letter as opposed to just the apple. So looking at this, I want the A to follow the apple. Currently, when I hit A, it doesn't. It stays there. I don't want it there. I want it to go with the apple. So let's see. We know a little bit about this right command, but we haven't really gotten too deep into it. But in your command sheet that I gave you here, if you actually go to the full turtle reference, this will go right to Python. And I'm going to search right and see what else I can find about it here. Okay, so let me get rid of this. So turtle right, the arguments move, false, align left, font. All right, so this is what the current parameters are and what we can set for parameters. So object to be written to the turtle screen, move true or false, align left or right or center, and then font. We've already set the font, so we get that. Currently, what do we have it aligned? Nothing. We don't even have the alignment on it. So turtle right home true align center. Okay, so by default move is false. So right there, if move is true, the pen is moved to the bottom right corner of the text. By default move is set to false. Okay. So based on that, I want the align to be changed here. I think I just want to set it to align center. So if I go back to my replit here, currently we just have the right A with the font. So I'm going to add a parameter. I'm going to add the align equals center. Okay, so that should at least put it in the center. maybe. All right, so that aligned it to the center. That's what I want to start with here. Okay, so looking at this, we have it centered, but we want it to go with the apple. We don't want it to just be there. So, all right, we're going to look at the y coordinates again. So if we go into here, let's see. We can start with setting the y. So active apple. And let's set the y coordinate. Let's get the current first. Set. Set y. Active apple. We'll look at the y coordinate. And then we kind of want to move it down. So let's move it down like 30-ish. Let's see what that does. Okay, so it moved that down, but it also moved the apple down. So let's move that back up too. So after it draws it, we actually want it to bring that back up. So let's go below it drawing it, and we'll add 30. Ooh. Oh, so we actually, that line, what did we see before? That line is actually caused by that whole pen up situation, pen down. So let's pick the pen up when we do it. Let me copy this. Put this in here. Let's see what we get. Okay, so that's somewhat there. Kind of want to play with this a little bit because I don't really like the position. Let's try 20. I want to get it in the center. Nope. 25. Oh, okay. I guess we'll try 35. See how far this gets us here. Oh, that's not bad. Okay, we'll leave it there. That seems like okay for now at least. Okay, so we got that like they wanted. Let's see what they want us to do next. All right, so proceed to step 11. Okay, once you get the letter to draw, you may notice that it doesn't draw right in the middle of the apple again. Oh, we did that. All right. You may have noticed your apple bouncing around, so when we click on it, let's see if it bounces. Well, not too much. Seems okay to me. To prevent this from happening, you can turn off the tracing of your turtle's path as shown below. Use the tracer method and or the update method in your own code to make sure the turtle's path is only being traced when you want it to during its fall. So I guess this is just making it so it's not always moving the apple, and it will allow it so it kind of gets rid of that initial bounce. You may see it on yours. I don't really see it that much on mine, but I guess that is something that does happen. Okay, so let's see what this actually does. Experiment with the sample code below to see how the tracer and update methods of this green class function. Alright, so I'm going to just make this piece full screen. See what this does. Alright, so essentially what it wants to show you here is how this tracer function actually works. So if I stop this and run it, see how you saw that line draw? If you set tracer to false, so, well actually, let me show you. If we set all these to true, what it's going to do, it's going to show every movement that happens. So see how it's showing everything that's being drawn? That's what the tracer actually does. It makes it so you can either show it or you can hide it. And if you want to hide it, you would just set all these to false. And that would still run the same lines of code here, except it's going to make it so you don't see that movement happening. And what happens with that movement, if I think this one has to be true for you to actually see where things are going. Because it does go back to the center, if you set them all to false, you won't see these go out. That's what's happening with the apple as well. So when the apple actually runs here, the reason you see it kind of bounce, if you see it on yours, mine's not that visible. It's because it's showing where that apple is originally starting on the y coordinate and then where it actually ends up. So it's showing this negative 35 and then adding the 35, and that's where that bounce comes into play. Okay, so that's the tracer, how the tracer works, what it's going to do for us. We're not even there yet. This is just kind of giving, where to go? This is just giving an example of, okay, when you use the tracer, if you want to make it so it doesn't bounce, here you go. All right, so let's see. Oh, need help? Oh, okay. So they're also saying, and this is true, that you have to, if you just want to see the final result, you'll call the WN update. So what that's going to do, we can actually see it here because we have it applied, is this will make it so it doesn't follow that tracer and it'll update your screen once you've processed the function. Alright, you don't want the apples and random letters being left on the screen once the user makes the apple fall. Use the following methods to remove the fallen apples and the letter the user types. So, kind of like what I said earlier, it looks like this is just going to be a game that when the user hits the letter, apple falls, letter disappears, apple disappears. Either another apple is going to reappear or they're just going to be all over the screen and you're trying to get them off the screen as fast as you can. So let's see, we can use clear, hide turtle, and show turtle. All right. Okay, so by looking at these, let's see, removes everything drawn by your turtle from the screen. All right, so let's try that. So if we go back to our replit, and we have, let's see, we're defining drop apple, pen up. Let's do apple.clear. Okay, so that gets rid of our A. That's a step. Let's see what else we got here. So it wants us to get rid of not only the letters, but also the falling apples. Okay, so we wanted to actually hide that apple also. And we just did the clear. So clear removes everything drawn by your turtle from the screen. Hide turtle. So this is the one we're going to use next. Make your turtle invisible. So that's what we wanted to do. So we'll go back to here and we just did the clear. So we can do apple hide turtle. And let's see what this does. So I press A. Okay, so it just deletes it. So I actually wanted to hide the turtle after it hits the ground or gets to this new coordinate. So I'm going to throw it in below here. Okay, so A. All right, so it goes away. Perfect. That's what we're looking for. Okay, so that works. Let's see what they want us to do next. Add randomness. Okay, so to this point, you have been making small changes to the Apple Avalanche typing game code. For the rest of the activity, you will work on larger portions on your own. This will require you to plan in advance and iterate on your design if it does not work the first time. Perfect. So, lots of stuff, I guess. Previous activity you've seen the randint to generate random numbers. After an apple falls from the tree, you will need to reposition and give it a new letter if you choose to correlate letters and apples earlier. To help you keep your thoughts organized, the two to-do commented program outlines have been included below. The one on the left outlines a program that correlates apples to letters, and the one on the right outlines a program that does not. You may find it helpful to copy the outline of your choice into a file in your folder for this activity. Okay, so let's see. I'm just going to copy this. Correlates apples. Yeah, I want to correlate the apples to letters. So we'll copy this, and I'm going to do just a new file. A to L. Just so we can kind of see what's going on. All right. Apples to letters. To do, create a function that takes a turtle as its parameter and gives that turtle apple. A new location on the tree. Only if the list of letters are not empty, associate the turtle with the new letter. So random letters. Okay, to do. Let's see what we got here. Okay, so this is using the for I in range. So this is using that range. So let's see. You have already completed parts of this code. You will not need to start from a blank. Oh, okay. So we don't need to start from a blank. So I think we're only going to use this, really. And we're putting our code in. I think we already did all this stuff. Because we did this. Function, the turtle, apple corresponds to letter. Okay, we're going to correspond the letter. Oh. Man, that likes to zoom in, huh? All right. So in each of the programs outlined above, you've been provided with an example of how to use the range function. Read the description in the code and search the internet to gather enough information to write your own description of how the range function works. All right, so Google it. The range function. Let's take a look. Google. Python range function. Let's see what we got here. Okay. The range function returns a sequence of numbers starting with 0 by default and increment by 1 by default and stops before a specified number. So range, start, stop, step. So the step would be if we want to increment by more than 1. Yep, because the default's 1. So example, x range 3, 6 for n in x print n. So we're going to actually have it do stuff with the apples rather than just print a letter. All right, so the range function increments, oh, if I can spell increments, from 0 by 1 default, can change step as parameter. Okay, we'll leave it that, and then I'm actually going to put this example in here, just so we have something to reference back. I really like Inkling because it does save your notes in here. So we'll have that. We'll do this also, the syntax for it. Start, stop. That way we just have something to reference. We could put this in our notes sheet as well, but since we're going through this activity, I'll save it in here and then I'll reference it in the note sheet later. So with this, essentially the range, oh, I forgot to add in here, function creates a list, increments from, so if we do range 3, 6, okay, it's going to look at those. If we do like range 10, it's going to go, I'll comment this, but it's going to go, like sequence it, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, because remember, we talked about this the other day, 0 counts. So when we look in the list and when we index the list, 0 is something that's in there. So this is 10 values in this index list right now. If we look at what they had here, because before they had X range, what was it, 2 through 6 or something? What this is going to do is it's still going to generate that list, but instead of starting with 0, now I'm giving it a starting parameter. So I'm giving it that value. In this case, it would be 2. So I'm going to do 2, 3, 4, 5. And it's not going to use 6 because the incremented value looking through that list, this uses 2 through 6. Or I should say the 6th value when it starts at 0. So let's see what they have below. Compare your summary of the range function. Oh, yeah, okay, so perfect. So, for example, range 10 creates a sequence. When called two arguments, range uses the first argument to start the sequence inclusive and the last argument to end the sequence exclusive. So 2 to 5 produces 2, 3, 4 because, like I said, it's indexing through that list. So it's just looking at the values in the index. So comparing for and while. In Python, a for loop with the range function is preferred over a while loop when you want to loop a known number of times. For example, for I in range, I'm going to highlight this, is preferred over I while. Okay, so this is like what we've been using in a lot of our programs. While I is less than 10, it's going to do something. So we're actually now migrating over using more efficient code. And for this, we would use this for I in range rather than creating that while loop. So it takes less code and is more efficient in terms. Yeah, so it's just more efficient. So up till now, we've been using this. It works. There's no problem with it. But like we said at the beginning of this activity, we really want to make our code more efficient as we go through. When we go to take the AP exam and when we go to write our own programs, this is just building blocks. So as we work through this and as we work on this, we're going to find different ways this works. This while loop works the same as this for, but when implementing in it, the for I in range is just more efficient than using this while. It's less lines of code and it's just cleaner. Actually stop here. I want to make sure that you have your rain function, what it actually does, put up in number 14. There's a lot going on with this adding randomness. It doesn't just want us to add randomness for the letters, it wants us to correspond or correlate the apples and the letters. So we're actually going to break this down as a class to make this a little bit easier to read than Project Lead the Way gives us. They give us some to-dos here, but in your activity 1, 2, 3, evidence that I'm having you actually upload in Canvas, there's a file there that we're going to take a look at, and I'm just going to break this down a little bit easier for you so we can actually walk through it and implement this randomness correctly, because there's more steps than this leads to. This makes it seem like, oh, just add random and call it a day and you're good to go. No, there's actually a lot we have to change. So if you jump over to Canvas and open your activity 1, 2, 3, we're going to take a look at that now.